and welcome to session 3. In this session we're going to get introduced to DNS and what it is, get some terminology out of the way, and then look at the installation of it. Just a basic installation, how do we get actually a DNS service up and running on a box. We're then going to look at the configuration options, because DNS as an architecture has many different deployment strategies, so we're going to look at what those strategies are. We're then going to look at the file location of the actual configuration files, and then we're going to look at how we can restart the daemon. So it's just a very basic introduction to DNS itself. A little bit about the setup, but a little bit more in this session about the actual deployment aspects of it. So first of all, some terminology. What is DNS? Well, DNS stands for Domain Name Service. And it's a service because it can actually have a lot of servers involved in it. So it's basically how we deliver functionality. So it's a domain name service. What does it do? Well, in terms of the service itself, the best way to explain it is, how would you like to remember lots of numbers? Not the easiest thing to do. What DNS does, it's actually a translation database. It takes something that is very human understandable, a name, a phrase, and allows that to be turned into the address, the IP address of a machine. So it maps an IP address to what we call a domain name. We'll be talking more about that as we get deeper into the module, but for the moment we can consider an address is actually simply translated from a name. So something like Google, instead of us having to remember the IP address or addresses, because there can be multiple, of where all their machines are, we just need to remember Google. However, what DNS will also do, it will also take that number that we have and translate it back to a name. So it does a forward and reverse translation. It takes names and gives us an IP address, it takes IP addresses and gives us names. So a simple example would be if we look up, say, the off-campus network in the laboratory, and we do an NS lookup on that name, what we find is we get an answer. And in this case, it says a non-authoritative answer, but it gives us an IP address. So a name translates to the IP address. So that's the most basic use of the DNS service. Now, how do we get that service, that functionality, onto our machine so we can start building our own architecture? Well, first of all, when we build our own architecture, we invariably link it to the larger internet, but we'll look at that in a moment. But to get our own DNS service up and running, all we really need to install is the package bind9. Now, if you're more interested in bind9 and who develops it and where it came from, if you go and have a look on the Internet Services Consortium site, isc.org/bind, you can find as much information in there as you could possibly want. There's also the support community in there, and one of the things we should be doing is if ever you're using any kind of support facilities, you should focus on what ISC are doing and saying in their forums. However, I would always suggest that you follow the way we're doing it in this module, because this is very much about the way it's deployed in industry. There will be a lot of useful facts in there, but as I say, try and follow the syntax and the layouts that I provide in the lectures. Okay, so when we've installed bind9, one of the other things we need to do is we need to have some utilities in there for some testing. So the other package that we should always put in with bind9 is DNS utils, and we can use either apt-get or apt to do the installation of those two packages. DNS utils provides us with some debug facilities, which is quite useful. Okay, so how do we get it installed? Well, if sudo apt install bind9 DNS utils, and that will install both those packages. If they're already installed, it will tell you, and it will update them if need be. So we run that command, it will come in and say it's going to take up some space on the box. Do we want to accept it? Yes. It runs through, does the installation, and that's it. We've got DNS on a box. Done. However, it's not quite that simple. There is a word of warning here though. When you install services on boxes, you need to be careful. Sometimes you install something as simple as that. It looks fine. It looks as though it's a straightforward installation, and that service is actually running already. So you need to be careful of that. We've now added some functionality to a box. It's a network accessible service, and therefore we have an attack point from a security perspective. So we need to be careful. We've installed it, it's up and running. Now what do we do to configure it? Well, that basic installation gives us some very limited functionality. We've actually got what we call a caching server just by doing that install. One of the things we can do is after we've done the install, we can actually have a look to see the process. So if we run the ps command, you'll remember that from previous sessions, ps-ef grep, obviously that's the text utility, and if we search for bind or named, we'll find that we get a list of processes. And if you notice there is a process which is owned by bind, process 635, and if we look along there, we can see it's running under user sbin named. Named is actually the bind9 application running, or sorry, the bind9 service running. So after we've done an install, we can make sure it's running. Now, how do we configure it? Well, configuring bind9 is predominantly done from a single folder, etc bind. And in there are a selection of files, and they all begin with named. Well, that's the configuration files anyway. We'll be looking at database files later on. But the configuration files for the basic way that we set up and have bind9 running and linked to services, to additional services on the internet, is all done through etc bind. Now, that said, we'll be looking more at that in a moment. But what we need to do now is we need to spin off and we need to think about how we're going to configure the service. We've got it installed, we know where the configuration files are, but what can we do with those configuration files and what kind of a deployment can we produce? Well, when we do the basic installation, what we have is a caching server. And we have a caching server that works in a very, very specific way. If we have our machine on the network, which we can see here, and we run a request for a name translation. So we send our request to our DNS server, and this is the server where we've just installed. The way the request works is, let's follow this through as though I'd said DNS, my DNS request was for google.com. That request is sent to the DNS server, and the first thing it will do is check its own local, what we call non-authoritative cache. It will look in there to see if that entry already exists. If it does exist, what it will do is it will, the DNS service will automatically from that machine send the result back to the client machine. So in some cases, you make a request and you get an immediate response back from the server you've just communicated with. The other way this can work is if we make the request, the DNS server will do a check in its repository. If it doesn't exist in there, what will happen is the server will go off and it will go to the internet. Now, there are two ways it can go to the internet. Initially, we're going to look at DNS forwarding. Later on, we're going to look at something called route hints. But for now, we're going to look at forwarding. We can supply addresses to our machine to say, if you don't have the answer, here is where you should go and look for it. So the machine, our DNS machine, will actually go off to those servers that we've specified and ask them for a result. And what they will do is they will then try and get that result for us and return it. One of the things it also does here, which is quite helpful, is when that request's gone through, if it has been forwarded and a result comes back, the server can do two things. If it receives a result, which is that doesn't exist, it will store that and then also tell the client machine that URL you just looked up doesn't exist. But our server has also remembered that it doesn't exist. If our request goes through and it does get a result, what it will do is it will store the result in the repository and send the result on to the client. So the repository could have two components in it when a request is made. One to say what the answer is, or secondly, whether that doesn't exist. If another client comes along and makes the same request, the answer will come directly from the repository. Now we have mechanisms for controlling that, which we'll discuss later in the module. But from a caching DNS perspective, all that our DNS server is doing is removing load from the back-end architecture which doesn't belong to us, because our requests are forwarded and then stored locally so that additional requests don't put load elsewhere on another network. So, to break it down very quickly, any query that's received is checked against the internal database. If it's found, the answer is returned. If it isn't found, the DNS server will forward on the actual request. If it gets an answer, it will store that answer and return the answer to the client. If it is not returned from the other DNS service, it stores that negative answer, in other words, negative cache. It does not exist, and returns the does not exist answer to the client. Any subsequent queries will be responded to directly from the internal database. So a caching server does quite a lot. One of the things it really does do is increase performance of searches. In this module, we will only be looking at two things: recursive and forwarded queries. Recursive queries means that the request is forwarded on. And forwarded means that if an answer is not available, if a query is made that can't be answered locally, it will pass the queries on to specific servers. Recursive, it will pass it on to additional servers, but it's normally the root hints. In our case, we're going to be looking at getting answers from other machines. So what about a primary server? We've seen a caching server. Well, what does a primary server do? Well, a primary server is what we call authoritative. And what happens with an authoritative query on a primary DNS is when the request comes in from the client to the server, not only does it have a local repository of cache, but it has specific individual databases set up for specific domain names. So let's say in here I had my DNS server and I owned a domain name that I was running in my internal network of, say, offcampus.co.uk. In here, I would have a database for that. Let's say I had a second one, say vbox.org.uk. That would be another database. So I've got two databases in here. And in effect, what this DNS server is saying is I own those domain names. So when the query hits that server, if it can answer the query, the answer is sent back to the client and says authoritatively, you are getting a result or a response with an address that I am the definitive source of. So a primary DNS is giving authoritative answers for zones that are owned by the organization. If we put these two together, we've now got our basic installation of a DNS, and it's a very powerful setup. What we have is clients can have authoritative and non-authoritative responses from the server. If we actually make a request and it's cached from the outside world, it will come from our DNS repository from external queries that are cached. If we make a request and it's from one of our local databases, we'll get a response from there. So we now have two areas where we can get responses. One is a cache from the internet, and the other is for our locally owned domain names. So the request can come in, it can get an answer from either of these areas. If it doesn't exist, it will still go out over to the network, to the broader network, bring a response in, and then cache the result here. And then we would get the response to the client. So now we've got the functionality of both a caching server and a primary server in one area. Now, when it comes up to giving ourselves some kind of resilience, what we can start doing is we can have a primary server, but we can now also have secondary servers. A primary server is the server that will actually manage or control the zones that we actually own, the domain names that we own. I'll tend to use those two names as the same. Sort of, I'll talk about domains and zones in different contexts, but they're the same thing. So a primary server is where it holds our zones. That's where we do all of the management. We can then also have a secondary DNS server. And what happens with the secondary is it is synchronized with the primary. And when it is synchronized with the primary, it holds a copy. And if any changes are made to the primary, they're pushed to the secondary. What this means is we now have two sources of being able to get an actual answer to a query. And both of them can actually do caching, and both of them are now holding the primary database, and both of them can use forwarding. However, this kind of setup, although it can be done, it's not a good way to do it. We will generally be putting our information or database information into our primary server, and we cascade the results to a secondary. So we really need to protect this, because if anybody managed to compromise this area, they could change where people end up based on queries. So although you can do a setup where you have two machines that link and you use both of them, and the reason you can use both of them is a client machine can actually be told there are two DNS servers. And what it will do is it will go to the first. If it doesn't get a response, it'll go to the next. So that would give us some kind of resilience on the network. It would also give us some performance increase, because if the primary server was being overloaded with queries, the query could be redirected from a timeout to the secondary. However, this idea of having a primary and a secondary linked and both providing the service on a network has implications that we really do not want to be putting out there. So the usual way that we would do it is we would actually have a primary server which is actually isolated somewhere, not on the network, isolated somewhere where it can be securely maintained. That is going to be where we actually carry out all of the updates to put new names in, etc. What we would then do is have multiple secondary servers. So in this case, we've got two secondary servers. Now, from a client perspective, there is no change. They simply have the two secondaries as being their name servers that they'll use. So a DNS query will go from here to the first of the secondary servers, whatever sequence we've put them in the DNS, in the name servers in the client. If it can't get a response from that server, not that it gets a negative, the fact that it gets no response, a timeout on a transaction, it will then cascade to the second secondary. So this is now giving us the same kind of resilience and performance, except we're now in a position to move the primary server and protect it. So the setup we have now is a primary and two secondary servers, and that's your usual minimum for any kind of implementation. Client machines should only ever point at secondaries. That's a good rule of thumb. Primary servers should only allow the secondaries to communicate with them. This adds a level of security. And likewise, the primary, you could put it behind a firewall or simply protect it with some kind of internal security like IP tables or something of that nature. So now that we've got that, what have we really got? Well, take the primary out of the equation now. We don't need the primary in this discussion. The primary is feeding the data to these secondaries. So where's the fault tolerance? Okay, well, the fault tolerance we've got is this machine can be forwarding to several servers on the internet, as can this one. This will be caching. So if a query comes from the client to this machine, goes to the outside world and gets a result, it will store it. Likewise, if we don't communicate with that and we communicate with this secondary server, this can do the same. If this gets a query it can't answer from its local databases, it can go off and get a result. We've got multiple secondary servers, so if any of these go down, we can always cascade the other. On the internet, if we are linking our forwarders to multiple, any of these servers could go down. So the only way we could lose our DNS architecture working is if both of these secondaries go down, or all of these external servers go down, and the chances of any of that happening are very slim. If you think about it, how many times have you been to a machine that is connected and functioning correctly on the internet, How many times have you not been able to type in www.google.com and go to Google? My guess is you've never been in that situation. So the fact that we have DNS to do this reverse translation for us, and we have this idea of caching information from the internet services and internet servers, and we can actually replicate with secondaries our internal databases that we manage, we have a very fault-tolerant, high-throughput DNS service. So how do we start changing that? Well, okay, we've got our caching server. Let's do something with it. Let's put some forwarders in. So we'll go in and we need to look at our main file. Now, the main configuration file for bind9 is named.conf.options, and that's located in etc bind. So if we go to that file and open it up, what we'll find is, I've just catted the file here, we'll see that it specifies inside options a directory. We'll come on to that later in the module. The next thing we've got is we've got a block, and in that block there's some narrative description, and if you notice right in the middle of there's some information about a security certificate. As soon as you do any installation of a service and you're going through any of the config files and you find something like that, you should immediately check it. So we'll do that. On top of that, you'll notice that there is a section called forwarders, which is cancelled, which is blocked out, and it doesn't seem to point anywhere at the moment. Well, we're going to change that because we want to tell our server what to use for its lookups if it can't answer. We don't need to worry about any of that at the moment. We just want to concentrate on that first thing we found, that certificate. If we go and have a look at the certificate, it gave us the URL. If we go through there and have a read, we can see that this is a known bug from an old version, so we don't need to worry about it. But we do need to check, and that's what we've done. So we can come back now and we can say, okay, first thing we want to do is we want to put some forwarders on. We'll discuss why we would use forwarders later on. So in forwarders, we put in the IP addresses that we want with a semicolon at the end. Now, these are just example IP addresses. But what we're doing here is we're saying, rather than have my DNS server go off and use what we call the root hints, we want to direct it to some specific machines. And there could be reasons for that. We may have an internet service provider who says, here are our DNS name servers, use them to cascade your DNS server into it. And we can do that. If we make that change and we want to start using it, what we need to do is we need to restart the bind9 service. To do that, we use the system control command. So we have to be a super user to use it. So sudo systemctl. The next parameter we have to put in is what we want to actually do with the service. And in this case, we want to restart. So we go sudo system control restart, and we want to restart bind9, which is the DNS daemon. We run that command, restart the service. When it restarts the service, what it does is it reloads all the configuration files. It also reloads its database files. But for now, what we've actually done is we've looked at the architecture of a DNS. What's its function? It's this translation. So we've looked at that briefly. What we've also done is we've looked at the package that we can use in Ubuntu to deliver domain name service, and that's bind9. And the other thing we've done is we've done a very, very basic setup of a simple DNS server. So what we've done there is we've actually installed bind9, put the utilities in, we've got the configuration file, and we've set up our machine to use specific forwarders. So our server is now a caching server using forwarders. So that's what we've done. So what we need to do now is build that in the workshop.